Hello class and welcome to Module 6.1. We're going to go over the web application-based attacks for security professionals and the OWASP top 10. So these top 10 are the top 10 vulnerabilities. These change technically every year, but often the vulnerabilities are the same. But sometimes a new vulnerability comes out and becomes overly prevalent. One of the examples is called clickjacking. It's when you go on a website and there's a ton of pop-ups and you see X buttons or OK buttons, and those aren't actually the exit out of it button. It opens another tab to something else. That's considered clickjacking. So that became very prevalent and popular. So that replaced a different vulnerability. But for the most part, these 10 vulnerabilities we're going to go through in this section have remained the same for a while because they are the top 10 most exploited. All right, let's jump into it. So overview, web apps use many different protocols, most prevalent being HTTP. So this part is just kind of some background on how HTTP first came about and why it's used so much. Before we actually start talking about the web applications themselves, we have to understand how we even connect to the web applications, which is part of some of the vulnerabilities. Um, so this course assumes that you have basic understanding of internet protocols. We've already gone over a few in the previous sections, but just things like TCP, handshakes, connections, ports, packets, all those kind of words and terminology you should be generally familiar with. This part will be a much more, in-depth dive on HTTP in particular because we're talking about web applications and most web applications communicate using HTTP or the more secure version now, which is HTTPS. So the first protocol is defined in RFCs, so it's requesting for comments 7230, 7235. So in the examples of this module, when we refer to a server, they're talking about a web server. And then when they're talking about clients, these are some of the examples of a client. So web browser like Google Chrome, your proxy clients, your API clients, and any other custom HTTP programs. So it's good to understand the difference between servers and clients. It's also important to understand the difference between a stateful and a stateless interaction. So for the most part, HTTP is considered stateless because it doesn't make a persistent connection. It has a request and a retrieve response. You have your web page and then you're done. The transaction is closed. Versus some other like FTP where you have to actually have a longer session. So you log into the server, you get your response, you're authenticated. Then from there, you say select a file you want. That file is then transferred, and that's a whole session there, right? Are all part of that one session. So that's considered stateful. So a sequence of transmitted and execute commands is often called a session, which is what I was saying beforehand. So here's a diagram of what it looks like. So you have your client, this time being the computer, a proxy server, the connection to the internet, and then the actual web server or the HTTP server. So a lot of these servers you'll see Apache. Apache is one of the more lightweight HTTP servers you're going to see or web servers. I don't know if it specifically says that here, but Apache is typically what you'll see a lot of servers running. So HTTP proxies can both be servers and clients. So the client connects to the proxy and acts like this is the server, and then this acts as the client to the actual web server itself. So here is the TCP IP protocol connection that HTTP uses, which is opening that handshake, right? We did that in the previous section. And then we do a request. So we say, hey, can we have this website? And then we get a response, which is the website's, all the information displayed. And then that's where it's terminated, right? So that's why it's, again, considered stateless, because it's not really a full session. It's just a request and response. So you can see here when we were using TCP dump, you can go ahead and grab all those packets. Here's the packet capture of all of the packets from this interaction that you just saw here. So you can see, this client is asking, requests, okay, and then here's the get request right here. So this is the handshake, and then here's the get request, and then you can see this is the response. So yeah, this is just explaining what I said. You see the first section is the handshake, and then it has the request, and then it acknowledges with an OK response. Each of these request and response message contain a message header and body. We'll talk about it, the different error or different response codes that HTTP does. You probably know, like HTTP 404 not found, right? Um, so we're going to talk about that in just a minute. But here's a Wireshark. Um, you might be familiar with this, or you should be familiar with Wireshark. Uh, Here's the actual packets being broken down to. So here we can see the GET request of the HTTP, specifically the Omar HTML. This is the directory we're traveling through. Here's our host, connection, etc. So you can see the full thing, right, in Wireshark. Uh, and then, so here are the different interactions you'll see in the header and body. So you can see them here, right? So host, connection, cache control, upgrade, user agent, etc. Right? So these are all the different arguments or components you're going to see inside. So you can take a minute to pause me here if you want to just go and read these. You're going to see pretty much always the get request and the header, and then sometimes you'll see things like delete, etc. This just depends on several other fields depending on what the request is, right? It can change depending on the server. So here's the response. So we saw our get first, right? So this is us asking the server, and now we're going to go to the server actually responding with the OK code, right? So here is the status code. Again, you'd see status code say 404 if the thing isn't found. So here we go. Here are these status codes, right? So 404, it's not found, related to the client. So the client is not found, right? It's not a server issue. It's the client's receiving issue. It's not found, right? So this is at the client asking for something that doesn't exist. The server says, hey, this doesn't exist, right? So you can see they're between 100 and 500. The first digit will tell you what kind of problem it is, right? So informational problem would have a 1. 200s are the OKs or successful messages. 300 are redirections. 400 are client errors. 500 are server errors, right? So the URL structure, you've seen it. If you've ever Google searched, you'll see this, string of information. Obviously, the part you know best here is just the HTTPS : // and then the website. And then here are the additional arguments that you can add. So we're going to go over this. So scheme, this is the protocol that's being used almost all the time. You're going to see HTTP or HTTPS, hopefully S. HTTP is not secure. So you can see, so HTTP, FTP, etc. Right? So this is the protocol we're using, the scheme. And then our host is where we're trying to connect to. So this would either be an IP address or a translated address. So we see here it's the artofhacking.org. And then our port is here. This is the port we're connecting to the server, so it's a pretty high port here at 8123. So default port for servers is port 80, but again, sometimes this port 80 is the server itself using connections to HTTP rather than hosting them or acting as a listening port. So often they choose, a higher port, right? So this is port 8123. That's not like a specific number. It's just a higher port that you can use for listening requests. So then we have our path. So this is where we're going to grab from. So it's the directory into test. So this is the path we're going to look for our HTML code or our page or whatever we're trying to grab. So yeah, the root is typically called directory. So that's what they're looking for when the server root. And then the path segment parameters are the arguments, right? So this includes the optional name pairs. This is kind of like telling it where to grab specifically on that page. So there's a lot of different, you're going to see either really, really long strings of information here, because it just depends on how the server itself is actually configured. So the path segment parameter is ID 89, right? So the path segment are not commonly used. In addition, it is worth mentioning that parameters are different from query string parameters. So these are the actual query strings. So we're gonna, here's the query string part. So it's the actual search. So this is the ID of the connection, and then this is the actual query after the question mark. So the query starts after the question mark. So in addition, other protocols such as HTML, like I said, is that a lot of things are coded in HTML and CSS. This is the structure cascading sheet style. It's kind of the prettiness of HTML. HTML has a very basic structure, and it's CSS is what makes it pretty and adds sliders and blocks and different colors and text styles, etc. Right. So moving forward, so the current versions are 1.1 and 2.0, and then this example of 1.1 Exchange. So this is we open our connection. So here's our handshake. We're getting this page, right? Here's our directory we want. It gives it back, and then we're going to get the cascading style. So this is going to make the page look pretty much. Then response here, and then we're going to get a script response here, whatever we accessed on the website. And then after it's rendered, because we have the script running, the CSS running, and the actual page, we close the connection. So you can see here 2.0 is multiplexing, so it's doing multiple gets in one, and then response, so it's a little more efficient. So a web session is a sequence. Session is sequence. Those two words always go together. And response transactions between a client and a server. These transactions include pre-authorization, authentication, and session management, access control, and session finalization. This is all the security / we'll say administrative work before you actually start doing your transaction, right? So many web apps keep track of these. You've probably heard the term cookie. That's one of the ways that they can keep track of them. So these variables apply to each and every interaction. So they're remembering a user and remembering all these, tasks, and then saving it to the user so they don't have to keep redoing this. Often they'll just have to authenticate, and they already have all the access controls and etc. set for that user, right? So, for example, an application can remember the user's language preference every time it visits the site or application front end, right? So you don't have to always select Chinese or English or Spanish or whatever language you want. So in short, web apps can provide session capabilities both before and after authentication. So even though they are stateless, they can still have the same benefits of a session, which is remembering preferences. So after an authenticated session has been established, the session ID, which is what we saw as part of that URL header, is the token. It's equivalent to the strongest authentication method used by the application. So these tokens are often the target of session jacking. These tokens are what you can use to re-authenticate to a server. So theoretically, tokens should always be a one-time use. That's not always the case, however. So if these tokens are not one-time use or don't expire in a proper manner or not set to expire in a proper manner, that's one of the ways people can actually take over your session. So we've talked about that a little bit in the previous sections, but we're going to talk about it more going forward. So pretty much this is just saying that this is the name and value. So it's the name of the session as well as the value of the session, whatever the string of information they want to use, right? So here it says a good set is 128 bits, right? So a good session ID should be at least 16 bytes worth to prevent brute force. So if you're in the middle of a session, you don't want someone to be able to brute force attack and steal your session ID. It says here, make sure that your random generator is 256 bits of entropy. This is still relatively secure, but as machines and our processing power becomes faster, this is probably going to need to be more, and this probably needs to be doubled, likely in the future. So there are multiple mechanisms available to maintain session state within web applications, including cookies, like I mentioned. This is probably the more popular way to maintain a session state. I.e. remembering your preferences. If you're a user, you're already pre-logged in, whatever it may be. So including the session ID in the URL can lead to the manipulation of the ID, right? So remember how we saw the ID in the URL? It's not a good idea to have that plain text ID there because, again, if someone is able to figure out that ID and follow the same query, they're now logged into your session, and that could be a problem if you have sensitive information. So the use of an encrypted communication channel also protects the session against some session fixation attacks in which the attacker is able to intercept and manipulate the web traffic to inject, so change the session ID on the victim's web browser. So having them connect, say, to their session if it's a malicious session, right? So there are non-persistent or session So these don't persist on the computer, i.e. they go away, and then persistent cookies, they stay forever. If a cookie has a max age or expires, it is considered a persistent cookie and is stored on disk by the web browser until expiration time. Problem is a lot of websites don't want to keep re-authenticating these cookies, so they'll put a max age of something ridiculous, and that cookie is pretty much entirely permanent for all intents and purposes, right? So modern applications typically track users by using non-persistent cookies. So this is like the more secure and privacy focused way that a lot of websites are moving to, especially with a lot of legislation being targeted to the tracking of information via cookies. So this forces the session information to be deleted from the client. So that way, if someone is able to get onto the client through cross-site scripting or some other method, they're not going to have all these cookies with tons of session IDs in them, and then they could use all those session IDs to log into your bank account, etc. Right? Um, so yeah, session IDs must be carefully validated and verified. These are the way that HTTP is able to know that it's you and how to pick up where you left off. So we don't want someone to pick up where you left off if they, don't have your permission, right? So this is the where they get or post parameters. This is where they get cookies, and then if web apps do not validate or filter invalid session ID values, and they just run them and they overflow, this can obviously become an injection, so you can run arbitrary code, or persistent cross-site scripting if the session IDs are stored and reflected backwards. So this is, a bad idea if we don't want persistent cookies to get reflected backwards, and then someone on another site doing cross-site scripting grabs that reflected, session ID, and then there they go. They can log in themselves. So OWASP top 10. So this is what this entire section's ultimately about. The last slides were more of a general overview of HTTP because we are talking about web applications and their vulnerabilities, and a lot of the vulnerabilities stem from the protocol, the overarching HTTP protocol. But the OWASP top 10 is the Open Web Application Security Project. This is like the general consensus of security experts everywhere. Like, hey, these are the top 10 things that are considered critical issues that you should always be trying to validate or mitigate or whatever you need to do to remove these from your program, be it web application, right? So it's an international organization dedicated to educating industry professionals, creating tools, and evangelizing best practices for securing web apps and underlying systems. So yeah, it's pretty much security experts everywhere get together and kind of agree, and as a council, like, hey, these are the biggest problems. These are the ones that we should let all of our other industry people know about. And these are the practices you can use to solve these problems so that they don't keep reoccurring. So publishes and regularly updates. Yeah, they're always updated, but like I said, a lot of the times the top 10's issues don't change. Like they're the same kind of general categories because they're seen all the time. They're just problems with the actual protocol itself, and it's kind of a necessary evil. So those problems, of course, are exploited, and that's why they remain on the top 10. So yeah, you can check out their GitHub. I'll go ahead and post that in the supplemental content if you want to look at it. It's a cool read to see how how they consider these problems to be in the top 10 and the examples and stuff they post here in the GitHub. So this course covers the vulnerabilities highlighted in the OWASP top 10. Yeah, we're going to talk about all the different top 10 vulnerabilities here. So and then, yeah, here is you could just keep up to date here with the website. I'm going to post that in the supplemental as well. And then this module covers vulnerabilities in the top 10. So it's not every single one, but we've talked about a few of the other ones previously. But we're going to talk about the ones that are more specifically HTTP/ web-based in this module. So injection and cross-site scripting. All right, so here's the first lab. This is where we're going to go find our vulnerabilities so that we can start talking about them. So let me pull that up. All right, so here we are, the first lab of this section. Nikto is a pretty good scanner. We're going to be using the GVM vulnerability scanner in the next lab right after this. This one is pretty much the default you go to when it comes to finding web vulnerabilities. This can pick up, your injections, your XSS, etc. So this is going to be our first dive into actually looking at these vulnerabilities in action. Kind of in our reconnaissance chapter, we've already kind of talked about how scanning, be it port scanning or vulnerability scanning in general is really important when it comes to pen testing. So this is going to be vulnerability scanning for web apps. So these tools are kind of the starting point that you're always going to go to. So, you know, you can't start actually patching vulnerabilities, etc., until you actually know they're there, as well as validating to make sure that you're compliant and you don't have these critical vulnerabilities running around on your server. So, anyway, similar to the other hands-on labs rather than the research labs, this one is going to be just some screenshots of you going through it. These questions are just kind of to help you follow along with what you're supposed to be understanding from these steps. So I don't need boxes. I just need you to go ahead and take screenshots of your progress. Many of you already are doing that great, so thank you. I appreciate that. Again, always do more screenshots if you're concerned that I'm going to mark you off because of not having enough information or not showing all the commands. But almost all of you, I would say pretty much all of you are doing a great job at showing your stepping through the lab. So I appreciate you and your participation. And again, reach out to me if you have any problems. So yeah, that's what for this one. Don't need the reflection questions, but yes, keep them in mind. Think about it right when you finish the lab. But the only thing I'm going to need are screenshots of you stepping through the lab. And then right after, we're going to go into, I believe, the next lab. Let me go pull it up real quick. Yeah, we're just going straight into the next lab. So let me go ahead and open that here. So similar thing. It's an open source vulnerability management suite. The GVM is also used as an open source scanner. It has a graphical interface, which is kind of cool. So Nmap, we've used Nmap already. It's a terminal only thing. So GVM takes that and puts it into a graphical user interface, which obviously helps with readability and is just more user friendly in general. Because I guess as human beings, a lot of us are visual learners, and just the blocks of terminal information can be a lot to actually digest versus the pretty graphics that GUI can create for us. So anyway. This is another important scanner that you can use for vulnerability scanning. It's another one to be familiar with. Especially when it comes to web applications. So same thing here. Just need you to show me that you're going through it. As you see, there are a lot of boxes in this one because it does want you to actually understand the differences of these scans and what you're actually finding in your results. I won't require the boxes for this one because a lot of it is just kind of understanding that these results are this issue, these results are that issue, and it's already kind of guiding you through that. So I'd rather just see that you're on the Linux one. So just take a minute. Part one is a lot of more information understanding versus part two, which is more of actually stepping through, as you see through the exploit once you found something to exploit, which is really cool that you could actually do that. So yeah, I don't need a ton of screenshots for part one. I just want to see that you have the GUI open and you're actually running through the results tab. That pretty much is enough. And then this is where I'll actually need to see the step-by-step on the command window, right? So, alrighty, that is it for this section. I'll see you in the next one.